Hello, I'm Stephen Veldhuis. I'm a professor here at McMaster University in Mechanical Engineering. I'm also the director of the McMaster Manufacturing Research Institute. Manufacturing matters, and that's our focus here in the MMRI. We're very interested in manufacturing processes and driving improvements to enhance competitiveness of the local industry here in our area. We're very focused on the process, and the process for one would be machining for us. We're interested in subtractive manufacturing that would take best-in-class materials with very unique mechanical, electrical, chemical properties and be able to machine those to get tight tolerance, high dimensional accuracy parts with very good surface finish and surface quality. Those kind of components go into the parts that you're used to seeing in automotive, aerospace, consumer goods, energy products, biomedical. All of those really require high performance components, and we can achieve that through machining. When we look at the machining process, it triggers a lot of very high temperature and heavy load interactions. We take the surfaces and we engineer them to be very specific to the materials involved in the process. We're working to try to develop very unique surface responses in those extreme environments so that the tool actually protects itself while it's in the process. So those oxides and nitrites form, and what we need to be able to do is supply the right alloys into the region and also provide the right conditions to form those. If we can successfully do that, we can make a system that's very protective and ultimately drive that to get higher competitive processes. When we think about how these components come together, these components ultimately produce the innovative products that you're working with every day: automotive, aerospace, consumer goods, biomedical devices, energy products. All of those are driven by high performance materials that require very advanced manufacturing. And that's our focus here, looking at how we can take the best processes and result in the best products. Manufacturing matters. We're really focused on the manufacturing process, and we're trying to drive improvements in that process through understanding of how the process performs. We do that by understanding through simulation and modeling. We try to implement sensors on our equipment, our industry scale manufacturing machines. We draw the data from those machines in order to understand how the process is performing, and we use that data to try to drive improvements. Our focus here is on the tribological interaction of those materials. So tribology is a study of friction and wear, and that's one of the main limiters to how a tool performs in a process. If we can drive an improvement, we can actually achieve a real competitive advantage. So the type of improvements that we're really focused on are self-protective behaviors of surfaces. So it's very similar to how callouses form on your hands when you're working in the garden. As you work with tools, your hands begin to form callouses that serve to protect your hands for further work. If we can achieve the same kind of thing in an inert object like a tool, we'd have a really good competitive advantage. So our focus is on trying to understand how those surfaces interact. We use that information to try to drive a very similar behavior. So ultimately, as the tool is interacting with the workpiece under heavy load and high temperature, we're forming oxides and nitrites that can be very protective. If we get the right formations to take place, we can actually protect the tool under very aggressive conditions, and we can drive performance while still achieving a long tool life. That combination really results in a competitive process, and that's what we're trying to deliver to our industry partners. So through close collaboration with them, we can duplicate their processes here in our shop, extract meaningful data from their processes, and use that to drive process improvements. High performance processes ultimately make them more competitive, which is what our real focus is on. Thank you.